Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we will solve some problem related to U-tube differential manometer. In our previous lecture, we have discussed the theory part of U-tube differential manometer. So let's solve some problem on the U-tube differential manometer. So I have taken a question. A differential manometer is connected at the 2 points A and B of 2 pipes. So 2 pipes are there. This is one pipe and another pipe is this one. So 2 different pipes are there. And as shown in figure, pipe A contains a liquid of specific gravity 1.5. So here the liquid which is present inside this, that specific gravity is 1.5, while pipe B contains a liquid of specific gravity 0.9. So here this is the pipe B where the liquid which is present, that specific gravity is 0.9. So the pressure at A and B are at this pressure point. The pressure is given A point, PA equal to 1 kgf per centimeter square, and pressure B given 1.8 kgf per centimeter square respectively. Find the difference in mercury level in the differential manometer. So here we need to find out the difference of mercury level. So difference of mercury level is nothing but H. Okay. So this is the mercury level difference is there, and we need to find out this H value. Normally we used to find out the pressure difference, but here pressure values are given and we need to find out the mercury level difference here. Okay, so let's write down this data given. So specific gravity given Sg for A point. At A point it is given for the liquid equal to, for A point it is given 1.5, so that we can write the density at A point equal to 1500, 1.5 into 1000 kg per meter cube. Okay, this is the first point. Second point we can write similarly, specific gravity at the second point, the second pipe B, that is given 0.9. So we can write the density of B point similarly equal to 0.9 into 1000, like previously what we've done. Similarly we can write this also 900 kg per meter cube. Okay, and next is pressure. Pressure at A point given PA equal to 1 kgf per centimeter square. So this one we can write 1 into 9.81 into 10 to the power 4 Newton per meter square. Okay, because we know that 1 kgf equal to 9.81 Newton. Okay, now similarly here we can write PB equal to 1.81 kgf per centimeter square is there. So this also we can write 1.81 into 9.81, 1.8 only, not 81, 1.8 into 9.81 into 10 to the power 4 Newton per meter square. So this is the conversion of these units. Okay, now we know the formula. One thing is the left side pressure and right side pressure. So left side pressure we can write. So this is the datum line we need to select. So above the datum line we need to consider. Okay, so the pressure above the datum line at the left side. So P at left side above the x-axis line equal to, we can write the pressure at A point, plus we can write this pressure value, this liquid, how much distance is there, rho gh. So this one we can write rho g h value not given. And next one, this total liquid from here to here, same liquid is there, so that one we can write rho a and g, and the height, total height is how much, 3 plus 2, 5 meter. So that one we can write into 5. Okay, so this is one side, left side pressure. Similarly at the right side, if you see, you can write pressure at the right side we can write this is nothing but only one single liquid is there with a height of some height is there from h to 2 h plus 2. So this one we can write rho b g and to h plus 2, because the total height h height is not given. We need to identify the h height plus the pressure at the pipe PB. Okay, so these are the things we identified from this diagram. This multiply symbol we keep. Now next thing is we need to equalize these two equations, this pressure at this A point and pressure at the B point. So if you equalize this one, we can write PA. Okay, we'll just directly write the value PA equal to how much? 1 kgf. That means 9.81 into 10 to the power 4 plus rho g. Rho g is nothing but density of mercury, that is nothing but 13,600. Okay, 13,600 kg per meter cube. Okay, now this value also you will put it here, 13,600 into g. G how much? 9.81 into h. Okay, plus rho a. Rho a is nothing but here 15 given 1500. So 1500 into 9.81 into 5. This is one side, left side pressure, equal to right side pressure. So right side pressure is nothing but PB. PB equal to this one, 1.8. So that one we can write 1.8 into 10 to the power 4. Okay, plus rho B. Rho B is 900 into 9.81 G into H plus 2 into H plus 2. These things. Okay, now this is the total equation for us. Now here we need to find out the H value. So you can see where the H value is there. H value only we can see at this point. One equation H is there, and this is one part. If you split this one, we will get only this part of H. So let keep one side all this H value, and remaining side we can take remaining values. So here if you multiply this value, just I'll keep it these things here, 13,600 into 9.81 into H minus this value 900 into 9.81 into H equal to, we can write this total all the things, 1 into 10 to the power 4 plus 900 into 9.81 into 2 minus remaining value things, this one minus 9.81 into 10 to the power 4 minus this one, this equation 7,500 into 9.81. Okay, so these are the value we kept, one side H value all, another side remaining all values. Now if you solve this equation, we can take common sum, like 9.81. You can see everywhere most 9.81 is there. We can take a common on that, and even 1000 also we can take common on this, like it means 1000 into 9.81, take common for all these values. But it will be easy for us to write this equation there. Okay, and finally if you see this H value, this term will be there. How much? 1000, 9.81 cancel, 9.81 cancel. The remaining how much will be there? 13.6 H minus 0.9 into H. Okay, so this value minus this one, we'll get something 13.6 minus 0.9. We'll get 12.5 H, and remaining other sides. So you'll get the H value here. If you see, identify this H value here, from this we can get near about 0.181 meter, or this one we can write 18.1 centimeter. Okay, so finally the h height is nothing but you got here 18.1 centimeter. Okay, so this is the problem. This kind of problem may be given in the exam. So if you know this formula, we can easily identify. We know the formula P equal to rho gh. So from that we can identify easily. Okay, and let's see another one problem of this. So here one more question I have taken. It is a differential manometer is connected at the 2 points A and B, A point and B point. At B, air pressure is given 9.81. This air pressure is given here at B point 9.81 Newton per centimeter square. That is absolute pressure. Okay, absolute pressure we already discussed in the previously. And find the absolute pressure at the A point. So we need to find out the absolute pressure at the A point here. Okay. Now similar kind of question. Now previously if you see, A point was here. Okay, this is A point, this is B point. Now pressure A is this one. Now here A is little bit down and B was little bit taken up, and here absolute pressure given. Now similarly here also we can identify what are the values of this. See, this is oil of specific gravity, this is water given. Okay, this is water, this is oil, and this is mercury given. So three different liquids are here. Okay, now similarly we can find out, we can write rho A. Rho A is given, specific gravity 0.9, so rho you can write 900. Okay, 900 kg per meter cube. Similarly rho B, rho B is nothing but water is there, so that one we can consider 1000 kg per meter cube. And this one height is given here. So this is the datum line is for us, xx line datum line is there. Now if you see the h value is given here, h equal to 10 centimeter. So 10 centimeter we can write into meter. That will be 0.01 meter. And next what we'll get here in this, any other point is there, this height. If you take this height the x1, then this one we can take y, or this one you can take y, this one you can take x. And rho g is given 13.6, that is specific gravity of mercury into 1000. So total will get 13,600 kg per meter cube. Okay, so these are the values given here. And h value 10 centimeter, then this x value 20, y value 60 centimeter. So directly we'll write down the pressure here. So pressure at this above the right side, this right side pressure only single liquid, you can write that one. So pressure at the right side above the datum line equal to what we can write, PB. So PB already given 9.81 Newton per meter square, plus we can write rho GH. So total height is given 60, so we can write that is 0.6. Okay, here it is 10 centimeter given, so that one then you need to write 0.1 actually, 0.1 meter, not 0.01. Okay, 60 centimeter, 10 centimeter. So here rho G, so rho B, G and H, this Y actually, that is 60 centimeter, that means 0.6 meter. So if you write this value, how much will be there? That means PB equal to 9.81 Newton per centimeter square. If you convert into meter square, then 10 to the power 4 we can multiply on this. So that one you can write 98,100 plus rho B. Rho B how much? Density 1000. We have taken 1000 into 9.81 again into 0.6. This one will get some value like, you know, calculator. Let's see. We'll get the value near about 1000 into 9.81 into 1000 into 9.81 into 0.6. Okay, 5886 plus 98100, 1,03,986. 1,03,986. 1,03,986 Newton per meter square. This is right side pressure. Okay. Similarly, we can write the left side pressure. How much? Pressure at the left side. That is similarly PA plus, again you will get two things here, H, again this one another one. So this one we can write rho G H plus again rho A G, and this height x1, suppose height is there, x you can write here, we can write y, this is x we can write. Now total again we can write PA. I think we need to calculate. Okay, PA need to be calculated. So that means PA equal to or plus rho G 13,600. So 13,600 into 9.81 into height h 0.1 plus similarly this one, this value is rho A. Rho A is given how much? 1000. Sorry, oil is given 0.9. So that means 900. 900 into 9.81 into 0.2. So this is another one equation. Correct. So in this equation only one unknown is there, PA, and here already we got the value of this one. So that means we can easily identify if we compare these two equations and write PA equal to 1,03,986. This one PV, this P at right side. Okay, minus all these things, this one plus this value, total we'll get here something like that, 13,600 plus into 9.81 into 0. This one 900, so we'll get near about 15,000 something we'll get here. 9,000 because it is 1. This will be 10, suppose this will be 10 multiplied into 0.1 1. So near about 13,600 plus similarly here also 10, here 2 1800. This is 13,600. So 15,000 here will come. So 1 lakh. This is 15,000 minus if you do, then we'll get near about 88,000. 88,000. Some value will get Newton per meter square. So if you write this one in terms of centimeter square, we can write 8.88. Some value will be there, actually 5 digit will be there. So 4 digit will be gone in terms of meter square to centimeter square. So we'll get 8.88 Newton per centimeter square, the pressure at this A point. So these two problems, I hope you understood how to solve these problems regarding the U2 differential manometer. If you are having any query on this, you can give a comment in the comment box. Thank you all.